Okay, I'm going to go over the second practice quiz for 7.1 to 7.3. Remember, on the front page for the quiz, you will only have to do one of the three identities. But we're going to go through all three just to make sure you have an idea of what you're doing. So anytime you have fractions, so we're going to start with the more complicated side. That's the side here with addition and fractions and all sorts of stuff. When you have fractions and you're trying to get down to one term, we're going to have to add these together. And in order to add them together, you're going to need a common denominator. So I'm going to multiply this one by sine x plus 1, and I'm going to multiply this one by sine x minus 1. Let's see if I can get a better pointer here. There, better pointer. When I do that, these happen to be conjugates of each other. So you will end up with a difference of two squares. If you don't believe me, you can FOIL them out. But you will get sine squared x minus 1. What I do to the bottom over here, I have to do to the top. So I'm going to multiply sine x plus 1 times 1, and just get sine x plus 1. 1 times sine x minus 1 is sine x minus 1. Up here, I'm going to have sine x plus sine x, that will be 2 sine x, and 1 plus a negative 1 is just 0. So my numerator is going to be 2 sine x. Keeping in mind my goal is I want a tangent. Part of what I want is a tangent. I want to use the Pythagorean identities to try to get this to be a cosine. So you have a couple options. If you look at the identity sheet that you have written out, you can plug 1 minus cosine squared x into sine squared x, and the ones will cancel out and you'll get negative cosine squared x. You also could take where you have cosine squared x equals 1 minus sine squared x, multiply everything by negative 1, and that would also get you negative cosine squared x. When you do that, cosine squared x can be broken up into cosine x times cosine x. Take these two together, or you could split it apart like I did. Sine over cosine is tangent. We still have the 2 from over here and the negative, we're just going to put those together. So we'll have negative 2, sine over cosine is tangent, and then 1 over cosine is secant. And that's what we were supposed to do. QED, give me something that says you are done. Back to number 2. Or, well, I guess this is still part of number 1. This one is a little bit harder to see what is more complicated. Generally, addition is more complicated. So I'm going to start with this left side. Because if I did the right side, I can't break apart the denominator. I'd have to figure out something to multiply by, and I don't want to do that. I don't want to figure it out. So I'm just going to go with the addition side and turn everything into sine and cosine, because that's the best way to start. So I will do 1 over sine plus cosine over sine. Well, hey, these have a common denominator. So I'm going to get 1 plus cosine theta over sine theta. At this point, I am going to multiply by sine theta. Why am I multiplying by sine theta? Well, because I want something squared so I can use a Pythagorean identity. And if I do sine squared, so sine times the numerator and the denominator, I'll get sine squared. And then I'll do the Pythagorean theorem, so I have 1 minus cosine squared. That is the difference of two squares. So I can break that apart into 1 plus cosine theta, 1 minus cosine theta. And hey, now those cancel. And I have sine theta over 1 minus cosine theta, which is what I was trying to do. The last one in this case is, I think, the easiest. So we have, again, the side with the addition, and we don't want to start with the thing with one term. That would just be ridiculous. So we have sine x times sine x over cosine. So sine times sine is sine squared. And this is already in cosine. So we have sine squared x over cosine plus cosine. We have fractions. Let's get a common denominator. So multiply by cosine over cosine, and we'll get cosine squared over cosine. We have the common denominator. So we have sine squared x plus cosine squared x all over cosine. The numerator simplifies to 1. The denominator stays the same. Using reciprocal identities, this will be secant x, which again is what we were trying to do. Pick the easiest one. That's all I'm going to say. It's not necessarily the first one, so pick the easiest one. Number 4 was like this on the first practice quiz. It will be like this on the second practice quiz. Yeah, you could use the half angle formula for number 4, but then you're going to have the ugly radical thing, where you're going to have to figure out if it's plus or it's minus, and you're going to have a radical, and you really just don't want that. So use a sum or difference formula. This particular one, I'm going to use a sum. So 75, not on the unit circle. Find 2 things that are on the unit circle that add to 75. So I picked 30 and 45. It does not matter if 45 is first and 30 is second, because addition goes both ways. So once you do that, you will have cosine A, cosine B, sine A, sine B. Plug it in. And at this point, cosine 30 is on the unit circle. Plug it in. Cosine 45 is on the unit circle. Plug it in. Once you plug all of that in, a radical times a radical, you can do that. A number times a radical, the number stays on the outside, so we have an invisible 1. We already have a common denominator because 2 times 2 is 4 on both of them. And you can leave your answer like this. Some things that will be true for every problem on here. If you are not using a formula, you are doing it incorrectly. All of these problems require you to look at your formulas. The other thing that students have a hard time with, once you find cosine of 30, that is radical 3 over 2. The cosine is not there anymore. Cosine of 30 is radical 3 over 2. There is no more cosine here. So make sure you do not take that along. So like I said, that's going to apply for all of these problems. If you're not looking at a formula, you're doing it incorrectly. So for number 5, this is a backwards formula. This matches up with sine A cosine B minus cosine A sine B. And if you look at your formula sheet, that equals sine of A minus B. Well, A is 110. It's 110 over here too. And B is 20. B is 20 over here too. So plug in 110 and plug in 20. That's sine of 90, which if you look on your unit circle is 1. Number 6, we have had several problems like this, where it says, draw a triangle, use a formula. If you're not using a formula, you're doing it incorrectly. So this one actually involves 2 triangles. We have theta and beta. If you want to, cross out theta and make it A, cross out beta and make it B. So this will be A minus B. If that makes you more comfortable, it doesn't bother me at all. It's all you need to know is that that's a variable. So we draw our theta, and I'm not going to walk you through this by now. You know, since this is going left, it's negative, up is positive, down is negative, right is positive. Hypotenuse is always positive. Once you have that, they told us do sine theta minus beta. Well, that formula is sine theta times cosine beta minus cosine theta times sine beta. Sine of theta, we go to the theta triangle. We find sine, and that is 3 over 5. Sine of theta is 3 over 5. The sine does not come along. Cosine of beta is 1/2. Cosine of theta is negative 4 over 5, and sine of beta is negative radical 3 over 2. Order of operations say multiply, multiply, and then we can add. If it's something that needs to be rationalized, you will have to rationalize it. That is just how that's going to go.